And we're live. I think I got the number wrong on this. Yep. Okay. This is day 198 of studying compilers every day in Thailand compiler role. I really want to try it out today, so I might just try to keep the stream short, but we all know what happens whenever I say that. So we'll see what happens. Last time we started the big rewrite of the front end. We got through a decent chunk of stuff before we got tired. Why is ping cord double pinging? Anyways, so that's what we did last time. This time we're gonna continue it. Hopefully we can do a little bit more cleanup of the stuff that we, I guess, broke last time, and hopefully we can also continue cleaning up more stuff. So yeah, what's good is Earth? Git log. Okay. Yeah, so we did a lot of stuff. I don't know if we need to clean up the parser at all. I think there are some things we need to like re-add into the parser. I think we should probably do that sooner than later. Specifically the assignment operators. So let's get that thrown in there. So under instruction. Yeah, a lot of this doesn't really make sense anymore. So we're gonna have some fun with this. The operator precedence. Yeah, that might be the big thing that we clean up today. So assignment goes over here. We'll figure out the comma operator eventually, but yeah. So I think these are all grouped under 14, if I'm understanding this correctly. This is very poorly diagrammed. Maybe if we undark mode it? Nope, still just as bad. Okay. Well, that's fine. Oh man. Yeah, this table sucks, but yeah. All of these are under like level 14. So I guess we can figure out what to do here. I guess we should throw it into Expert, and then we can go from there. What dark mode extension is that? It's just dark reader. Yeah, this one. Okay, this is not terrifying at all. So 14. So we want like struct expert 14. I don't really know what to call it. Alright, so this goes right to left. I think, yeah. This should... Yeah. This should be parsed right to left. Or associative right to left. So we can reuse what we did for like level 2, I think. This sort of structure. Just so I don't forget it, we're gonna have this up on the side. Yeah, there's a whole like Clippy unit for or there's like a whole Clippy movement that was started by like Louis Rossmann for like I don't remember exactly what, but it might be interesting to read up on. Okay. From where do you come from? I'm from the US, yeah. Okay. We have struct assignment, or assign, I guess. So this is, how do we want to do this? Yeah, this parses a little bit interestingly. So let's just paste this for a reference. Pectoral try, and then we want a sequence of something. So we want, oh man. So we want, yeah, actually how does that look? We want expert 2 on the right. So something and then expert, or expert 14. So we want ignorable probably, because we want some sort of a space, potentially. So I guess equals. I think that's what we called it in core. Yeah, we called it equal. So, so then we have another ignorable, and then we do something here. Oh man. Probably a level down then, maybe is how I want to parse it. Yeah, how did we handle these up here? Yeah, so I think this would be like x per 10. Yeah. So this is how we would do recursion in that direction. So then we'll figure out what x per 14 is in a second. So let's add the rest of these. So we want add assign. We want sub assign. Mul div. I think that's what we call these, right? We gave them really long names, but that's fine. We'll clean that up in a moment. Oh no. Okay, let's format that later. So what else do we need to worry about? Or what else do we have like what else do we have like accounted for in instruction? Add submul div. We have the shift and then all of those things. Okay. So let's do L shift assign, R shift assign. I was using my friend's computer and you're on his recommended? That's crazy. Well, I mean, I guess something about friendships having similar interests, right? Yeah, good to see you here as well. Okay. And then we have XOR, and that's the whole pile. Oh boy. This sucks. Yeah, okay. So we want add should be plus equal. This should be minus equal. This is asterisk equal slash equal. This should be, oh no. less and greater. Oh no. Greater. This is ampersand equal. This is pipe equal. And this is caret equal. Okay. I think we figured that out very uglily. Okay. Oh boy. So now we need to actually declare 14 properly. Okay. So this is pectal S, or this should be SOR, I think. And we can do something with that. We both know little to nothing about software / coding. That's insane. Yeah. Wow. I guess, I don't know. I think a lot of like, there's like the more like businessy / like front end / like web devy side of like software engineering, and then there's like this side that is considered like generally more nerdy. So like this is where like compilers lives. All of the like systemsy people, they usually use like NeoVim, or like they have some like crazy takes about front end, and like they think they're more superior than like all the normies. Like I think I think that audience is more where LaTeX generally gets bundled in. So I guess that might be why. Like, if you've ever seen like Sylvan Franklin's channel, wait, what? Huh. Okay. Well, that sucks. Yeah, that really sucks. But yeah, he had a neat channel. He's done a lot of like interesting stuff. He's like a math major. He has a lot of like he had a lot of Neovim content, and then, well, that happened. So that really sucks. But yeah. Yeah. Oh well. Yeah. Anyways, so that's like kind of like the example I thought of. If you've like seen his content, like you'll know exactly what I mean. If not, like, unfortunate. What's good, John? Why does Google say long live Jude? Yeah, I don't understand that sentence. I think it is like it's very up in the air, I think. I don't know. The sentence did not sentence to me. What are you writing a parser for the C language? Or at least a very narrow subset of it. Okay, what order do we want to look at these? Let's do add, assign, sub, assign, mul, assign, div, assign. We want normal assignment at the end, I believe, just to avoid issues. Or assign. Oh, I see. Is JIT faster? It like depends, right? Like, because like I think JIT also involves an element of like profiling, and I think optimizations for that can also like be more aware of that. So it's actually like kind of convoluted. Okay, I think this is about what we wanted here. What's good, Skittles? Did I do this correctly? It's just an S or of all of these, and then we also want expr 10 inside here. Yeah. I mean, yeah, like node probably won't be, but like I can see an argument for it at least, you know. I think I use all of these, right? L shift, R shift, and or XOR. Okay, neat. Speedrunning Java projects? Damn. Good luck on that. Okay, we have 14 created. And this should recurse correctly. Yeah, I mean, node is something special, you know. Okay, so we need to parse this. Yeah, this makes a mess actually. It is nice that we have a new op for this, so. Ref cells and Rust, hell yeah. Oh boy. I don't know, my brain is like not functioning right now, so apologies if I'm running at like half capacity. Let's yoink half of this. Yeah, let's yoink that. Where does this go? Probably at the bottom here, right? Can we do that? Does that work? Okay, yeah, that renames those, which is fine. And then we can We can sub out the body in a second. The body, we can kind of just yoink this, right? Like, just instead of or, we can do like add assign. Hell yeah. Okay, so this is sub assign. Yeah, I do not have full capacity in me right now, I can't lie. You will just have to deal with it. And distributed does not sound like a fun class for does not sound like a very fun class for Java. Our distributed class is in Go, which like makes sense, but like I don't know. It's a little bit odd not seeing like fully like systems level stuff for distributed. But I guess it's all like kind of theory, right? So it makes sense. OOP is genuinely the easiest CS class I've taken. I guess that makes sense. Yeah, I think like it's like you like learn the content. It's like going through a textbook, I guess. Yeah, we've got the world's leakiest cache in my brain right now. Man, I should make a macro for this. Like a C macro for this. This is so duplicative. Yeah, that's a cache miss. That's a cache miss right there. Page fault. Everything is page faulting. Oh my god. Doing everything I've already learned but with more well-defined rules? Yeah. I mean, that's like the whole point, right? Like they're patterns, but they're also like secretly anti-patterns in a way. Like, or like you're programming against the language in a sense. So like the visitor pattern is like a really good example of this, right? Because like you're trying to like program in a functional way, but in a object-oriented language, and that necessarily won't work out. Okay, we've parsed all these extras now, so this is a good start. This also means we don't need this stupid last op equals thing anymore. Thank goodness. That would have been terrible. Yeah, we are somewhat fans of object-oriented programming here. I'm kind of like forced to use it here for probably obvious reasons, given this silly little language that calls itself C++, you know, like it's kind of just like inevitable. Okay, we can narrow our instructions now. So we can delete this whole pile. Thank goodness. That whole thing caused me so much mental headache. It felt really awkward. Oh man. This we can keep. I think these we can keep. We can keep assign. Let's actually just look at our AST, and then we can parse off of what we have defined here. Or I guess our instructions list. So we have, yeah, so we have scope, we have just straight up expr, yeah. We have our control flow structs. Okay, so we have declaration. There's two types of declarations. That's fine. It's just easier to parse that way. And then we have assign, which doesn't exist anymore. We have opassign, which doesn't exist anymore. We have return still. We have if else, while. Okay, nice. So we can get rid of these two. But declaration assign still exists, just for parsing simplicity. We still need it for like our declarations. Stood variant, yeah. Like if you watch my friend Aiden's stream at all, like he's taking our compilers class right now, and he's like doing the work on stream on occasion, and this stood variant, man, we hate stood variant out here. You either have OOP or React. That's so real. Haskell is like you specified industry, so I don't think Haskell really counts. What type of compilers do you want to specialize in? I guess I don't know if this is like I don't know. I guess like general purpose language. Specifically working on like middle end stuff. I'm like pretty compiler agnostic about that. Okay. I think this is all good. No MLIR money? I guess like maybe MLIR is also on the list of things I want to work on. I have some ideas, but we'll see what happens. Supposedly like one of our classes is gonna cover MLIR in the future, which will be very interesting. What changed? We need to, okay, we can change this. We can just do that. Assign doesn't exist anymore, op assign doesn't exist anymore. Oh, that's it. Neat. Okay. So that's all of instruction done. I think function was fine as is, so that parsed fine. Okay. Let's see if this even builds. I think something is gonna break in 2 seconds. Yeah, okay. AST to HR. This doesn't really make sense anymore, because we're kinda nuking it, right? So we're gonna need to figure out what to do with that. I'm focusing on MLR/hardware accelerator/optimization, AMD, NVIDIA. Yeah, that sounds pretty reasonable. That sounds very like backend. Actually, I don't really understand like what specifically gets targeted there. I guess like what happens at the MLIR level? Because my understanding was they just needed like to generate backends. If you learn web dev as a newbie, you'll fully not learn OOP. Yeah, you don't need it if you just want to do web dev, honestly. Like Python is fake OOP. What did I do? Okay, let's add everything. Optimization passes. Okay, so I guess that makes sense. Like front end agnostic or front end non-agnostic specific. That's the word. I guess that makes sense. Nothing needs to change here. No, we got rid of that, so that's good. Okay. I think all of this is fine. Okay, this is parse with new assignment expers. MLR retains type information. I mean, like, but like LLVM proper also does, right? So it's a little bit hard to, I guess, differentiate. I guess like you can think of like the further down you go into a compiler, the less information you have from like the source language. So I guess like operating at that higher like language specific level is also kind of interesting. Like that is like the whole point of like Clang IR, for instance. So I guess in that sense that makes sense. Yeah, well, the thing is, right, like juniors aren't even writing React anymore. It's not even like juniors doing the writing. It's juniors prompting. Let's go to Aglover. I just want to say keep it up. Thank you. I will make my best effort to. Okay, so the parser is cleaned up. The preprocessor needs to change 0. The AST we cleaned up last time. Okay. So HR, I want to delete this right now, but I think that would be ill-willed. So we're just gonna, let's see. What do we want to call this function? Because I don't really like this thing to thing thing. What did I just say? I don't like this this IR to IR thing. Thing to thing. That's a new one. Okay. Because I don't like this as well. I guess we could call it like... We can move this into LR and call it like from MIR. And then here we could do like the other direction, so like to HIR or to MIR. Let's put it in here, yeah. There we go. Types? Hell yeah, we love types. We love types out here. Oh my god. Say no to LaTeX. But also like a lot of places that like don't take types, so still use LaTeX. But like types is so cool. We love types. That's the point of MLR. Have an IR for various attributes. I see. That makes a lot of sense. Yeah. I guess that's like also why it's like trendy now, because like it is the like one thing we can actually be proprietary with. So that seems interesting. Maybe maybe I should like mess around with some like MLIR stuff. I wonder if we could do some like MLIR stuff for Rust actually. We don't need MLIR for that. That's the entirety of the Rust compiler actually, huh? Oh well. Enough brain fog. Let's see. What do we even do here? Oh man. I think we should just rewrite this completely from scratch. I think trying to figure out how to combine this with this is going to be a monumental task. And that just seems like way too much work for my whatever the hell semblance of brain is. So let's figure this out. We need that for sure. We need that for sure. I guess we need these as like a bare minimum, right? Or let's put it in the other file. Yeah, so we want that. Cloud not doing a whole lot of function currying when you prompt it for a component. Rust prevents you from writing unsafe code by just preventing you from writing code at all. It's so real. It's like, I don't know, like this is like one of like the big things that I've been like thinking about recently, just in terms of like my own research. It's like there's like this whole idea of like safety, right? And it's like we tout this as like a big benefit of like Rust. This is like the big thing we've been designing languages around. Like garbage collectors are supposed to like solve memory safety. Like we add types to avoid like type unsoundness / like type safety issues. But there's always this like trade-off between safety and this idea of like expressiveness. And like if you've done any semblance of like PL thinking, this should be like a pretty obvious trade-off to make. But like then you get into like things where it's like Python doesn't have like a very strict type system, and you're like sure, it might be unsafe, but does this like, is this unsafe, or is this like, does this just mean like the language is very expressive, right? Like naturally, like with more guardrails, like you will be able to write less programs, and that like is the definition of like a language being less expressive. So yeah, that's some food for thought. I'm not really sure where I fall on this. It's always like very case by case, but it's all like it's very interesting, right? Because like a language that's like completely safe is also just like not expressive at all, because you can't do anything interesting with it. But a language that's like very expressive allows you to like shoot yourself in the foot. So yeah, that's my little PL rant. You study compilers at uni too? Yes, my master's thesis is specifically about compilers. Okay, let's... Oh man, this is gonna suck. This is gonna really suck to write. Okay. So we probably want something like this. I guess we could call this like lower. We want, so we want like that. Oh man. Yeah, this is rough. This is really rough. I don't know what to put in here. Because, like, this is very much like an interfacey sort of thing, right? It's like, do we want it in, like, the public header? Right? Like, this is interesting. Learning TypeScript basically just trains you to never write anything that could fail. Well, no, but, like, it's like stupid. Because, like, if you, like, look at how TypeScript handles types, it doesn't actually, like, do type checking. Like yes, you have like a linter, but like you look at the way that it resolves the types, it doesn't insert like type checks at runtime. It just deletes the types. Like it compiles down to JavaScript by the backspace key, and like they tout this as a good thing, and like it makes sense because like it's gonna be like slow as shit otherwise. But like it just irritates the hell out of me. Like what are we doing? You know, like why is this the point that we've gotten to? Okay, let's do that. Let's see, what else do we want here? I guess we could start with this. What's the point of runtime checks if you can prove correctness statically? You can't though. Like, you can pass a string into a function that takes, you can like pass a string that takes a function, or pass a string into a function that takes like numbers, for instance. And like it especially becomes a problem when you're mixing like TypeScript and JavaScript code, which is like also kind of the point of it, right? Like, the idea is like you can like slowly migrate JavaScript code over to TypeScript, but like if you have like a type error in like your existing JavaScript code base, that will only get caught once you migrate it over. But like the interoperability won't necessarily catch bugs. And like that, I don't know. I think like it's like probably fair enough, but like still, you know, it's like brah. Okay, this is gonna be rough. Okay, let's just copy the entire visitor over, I think. Or at least let's just rewrite the visitor actually. We can shorten the name as well. And then we can yoink this stuff. Can you not make like a non-null ref type thing in TypeScript? The point is that TypeScript necessarily doesn't insert runtime checks because that degrades performance. So like, I don't know if you can, but it doesn't matter because it's not going to check like function input necessarily. Oh boy, this is gonna suck. This is gonna really suck to write. Oh. Can we just put this in the C++ file? Is this a thing? Local, wow, that's a thing? Wow. Okay, wait. So what happens if I put this in the C++ file? Just out of curiosity. let's do that. I'm about to using this. Oh wait, it just lets me do that. Nice. Okay, yeah, well that actually makes a lot of sense. I want that to be like hidden from the header. Whereas like all of these are like data structures, so I think that's like fine to keep sort of public facing. I'm starting to think that this parser structure was a little bit ill-informed though, now that I look at it like this. Yeah, maybe I should start using an include. I should start using an include directory. Are you using inheritance? To some degree, yes. Like we are inheriting from instruction visitor and expert visitor, and there's nothing you can do about it. Okay, let's see. What do we want to do here? Let's take a second to like look at the include directory, because this is something that I've like wanted to worry about. Let me check something. Okay. Let's see. How do we want to do this? Is there like a convention for how the include directory should work? Local header versus include directory header. How do I want to do this? Okay. And add the library's include directory. Okay. Okay, we could have fun here. Yeah, we could like package that in a different way. So what do we want to do? Name a design pattern, the strategy pattern. I could not tell you how it works. I don't remember exactly what it looks like, but I know it exists. That was the answer that goes beyond the cop-out visitor pattern. Because all I use nowadays is the visitor pattern, I guess. Yeah, call me basic. I don't care. You'll have to deal with me only knowing the visitor pattern and having to like scrounge the depths of my mind to find anything else. Okay. So in here, let's see. Favorite design pattern is Rust. That's so real. Rust has like its own design patterns. It's like really funny that this exists. So yeah, that's also a little funny thing. There's also anti-patterns. Okay. So how do we wanna do this? Let's see. I guess we could just make one big front end header, right? And that would probably be able to encapsulate everything, since these are going to be like internal, and we can make like an external header pile, right? Like we can figure that out once we get there. Yeah, I guess we could just work off of this. We could just put the thing in here and call it a day. I don't think it's really that bad. I think this will clean up our structure a little bit. And then we can have like public facing headers, and that will be fine. And we will do that at some point. Yeah, the React pattern is a ball of yarn. Okay, so let's. Oh man, this is gonna really suck to write. So let's just yoink all of this because we need that for sure. Ah, well, we don't need these because those don't exist anymore. Oh no. So we need to do a lot of different things here, actually. So let's like list them out here in some capacity. So we want lowering tasks. So we want to descope. We want to handle, or let's just like look through. Let's look through what our current like lower function does, which is at the bottom here because I messed it up. Overrides, because we're overriding the things in here. Yeah, I have taken the bait, hook, line, and sinker. Okay, what do we need to do with this? So we need to descope, we need to so we need to descope plus resolve scoped vars. And we need to handle missing returns or terminate blocks. Oh man, this is gonna suck. We need to make basic blocks in this. Oh no. Yeah, I guess this is fine though. I don't think we need to do that much more. Yeah, okay. This is probably fine. I think that's good tasks for this, at least. Yeah, this also gets rid of this like awkward double table thing. What else? What else task-wise does this have to do? Oh man, okay. This is gonna be really hard to write actually, I think. There's just so much stuff that we need to worry about. Link, basic blocks, link, functions. I guess resolve. I guess that's what we can call it. Yeah, hopefully this also lets us clean up this code because this was terrible. This was not great. Just period. Yeah, okay. I think that will be fine though. We just gotta do something about it. Okay, so that's a lofty list of tasks for this to do in one big function. Oh man, this is gonna suck. This is gonna really suck. Okay. Okay, where do we even begin? Let's not put that there. Let's just put lower here for now. And then we can figure out what to do with this. I guess we want one big visitor that we reuse, ideally. I think that's how we've always structured it. So we want like 2 MIR visitor, TMV. Nice. We want to do something with that. And then for each function in its functions, Hmm. Okay, this should be fine. So you probably want to give this like get symbol table. Probably want that at least. So you should probably throw that in here somewhere. Symbol table star st, like that. Nice. Okay, and then we'll define all of that stuff as we go. We can figure this out. Maybe we should be able to like visit a cross function, huh? That might actually be smart. We should definitely do it like that, I think. Let's see. Getters and stars are hilarious. Yeah, I'm starting to realize maybe I should have just used structs for a lot of this, because this is necessarily supposed to be like internally mutable. Like unironically, it was a bad idea to use classes for everything. Okay, let's go back to the AST real quick. I think we want a function visitor. I really do think we need a function visitor here. I think that will help a little bit with clearing up the slop. So how did we do this again? Yeah, so we do that. We'll just copy those lines. Function, definition, F, prototype. There we go. And then we don't need to implement anything on that end. But that will help a little bit with hell. Yeah, so we can at least like move the stuff around a little bit. And that'll let us like that'll clean up the code a little bit. Maybe it will actually, maybe it won't. It probably won't. This also needs to public st function visitor. And maybe that was a mistake, but you know, it's fine, right? Like, let's actually move that up to the top of the list. Like that. Okay. You make them more complicated? Yeah, that makes sense. I guess mine are like pretty boring though. So I guess like it might have been better to use structs. But also like we have like unique pointers. So it's like, it's a little bit like awkward. I don't particularly want to pass around the entire unique pointer. That kind of makes a mess, and it just generally, I think, leaves more vector for things going poorly accidentally. Okay. Oh man. Can we just visit F like that? Oh yeah, we can we do that? Or wait. Oh wait, we need, what am I doing? These need like an accept. Oh man. So we got F, accept. Yeah, we're gonna need it to look like that at least. We'll figure that out in a second. A second means now. A second means now. Let's add that to functions. Let's see. Where's our accept? Okay, and then we want that. I don't think do we need to overwrite? Yeah, we do. And then we can paste that here. And then I think we need to forward declare function visitor as well. Like that. There we go. So now all of that is big chilling. It's probably more correct to move it like that order. Okay. So that's all good. We can figure out what to do with that later. We should implement accept real quick. Just for consistency, did we put that after toString, or would we put it after toString? I think we did that here, right? Or it should be like the last thing, maybe. Expert definitely has toString, so we can look in there. Hey, I just wanted to wish you good luck on your journey. Thank you. Thanks for popping by. I appreciate it a lot. We definitely have it in backend, maybe? I hope we do. Please don't tell me we made a mess. We made a mess. Okay. That's perfectly fine. Okay. Okay. What if we made the visitor like, we could undefault some of these and just make them void, right? Or not accept, but like the visit. Alright, that's probably like the more correct way to do it, I think. Right? Right? Can we just do that? Is there a reason to do that? Okay, we should default it, it looks like. Doesn't look like we need to, per se. Oh, that's C#. Guess it doesn't really matter, to be honest. Oh man. This sucks. We'll leave it as is. I don't want to make too much of a mess out of it. Okay. So what else do we even need to do here? Alright, this is all fine. Did we implement them? I think I forgot to implement them in all of my yapping and thinking about ordering. Yeah, that's definitely what happened. Yeah, this is gonna be a very boring implementation once again. Why did I make toString a visitor either? This was really dumb. I should just put toString on the actual things. Why, like... I hate everything. I hate everything. This really sucks. Okay. Yeah. Maybe I will just move toString out of the visitor pile because it is like pretty intrinsic to the thing. Okay. So we have that. Or this is definition. And then we want prototype down here. Yeah, I guess this also means we could move this into the whatever. It's fine. I'll reconcile this at a different time. ToString as visitor ? I guess. Yeah, we'll do that. That will kick the can down the road surely. Okay. So that's implemented. Now we can go back to hell. Yeah. So we accept that. And then we want to do all the other tasks, right? So looking here, so descoping we do as we visit, I believe. Terminating blocks, I think we also are supposed to do anyway. So that should be fine. Yeah. I know we definitely do that at some point. So we definitely should handle that. We want to resolve edges and we want to resolve functions. We should resolve edges in the function. So this should be resolve functions. Yeah, we should do that. And then we can figure out what to do with that from here. So then we can do like void resolve functions. At some point we will want basic block edges, I guess. We can definitely steal some of the helpers or the names that we've given them in previous instances. Like, what are we doing here? I think we've lost the plot a little bit with this. Okay. What else do we want to do with this? I'm starting to think I want to write some macros, which really sucks, but you know. Yeah, we should. I think this makes more sense as a name compared to connect basic blocks. Because then, like, that's like thematic. Okay. Oh man. This really sucks. This is so bad. I hate this. I hate this much. I hate this plenty. Yeah, this one's got a lot of state. I don't like how much state there is. There's a lot of lists and a lot of maps. A lot of buffers. So we'll start with that for now. And then we want like get result probably. So we want like let's do std string or wait, no, we want std vector or list maybe? We can do that. Is that the type that we used in here? List of basic block. What the fuck? Okay. Oh, duh. Wait, we want functions. We want functions. That's what we want. Oh, but we connected them like this? Oh, because we're okay. We definitely handle it differently. So I think this is fine. As long as we make this list of oh man. Yeah, how do we do this? I guess we could just like put it I guess we could just put it in here. Right. Yeah, so we can do that, and then we want like a. Yeah, we should do. Oh my god, no, I don't like captions. We'll figure this out in a second. I think we should do std list of basic block. I'm not sure why I made them unique pointers though. There is a reason, I think. Because we do necessarily need to point around to them. So we should make them unique pointers, I think. So we can do that. Yeah, so that's ugly, but it's fine. Just to double check, did I format toString in the header the similar way? Yeah. So the constructor, I guess this should be separate, right? This should probably be separate. Yeah, okay. Okay, so let's keep going on this. So then we want to do that. We probably want to copy the list from here. Yeah, we can do that. We definitely want that. Or actually, each function will just vomit out a function, right? So we should just make the getter a function, right? Surely we should do it like that. We should definitely make it a function, yeah. We should just make the getter a unique pointer to function, yeah. What's good, Narash? Good to see you. I am struggling to write code per usual. It's still pretty lobotomized. Right, we want to do it like that. What is wrong with this? Oh, whoops. There we go. So we can do that, and then functions, push back, get results. Or we wanna, I think that should work, right? Do we need to move that? I don't think we need to move that. We'll find out the hard way if we do. Okay, that's fine. So we can do that. And then here we should do the cleanup. So, what's your stream schedule? It's daily. It's supposed to be at like 5:30 CST, but I have a very bad habit of pushing it back or being late to my stream or doing both at the same time. So it's not really consistent. It is pretty much guaranteed to be after 5:30, and it is probably guaranteed to start before 9. And it'll probably start somewhere in that range though, on most days, if not all. Or, again, supposed to, but we all know what happens, I guess. Again, CST, so Central Time. Okay, how did we finish this up? We can just yoink from here. We can just construct it like that. That's really cool. And what is literal map again? Oh, I remember this now. That's what we needed. Oh no. Okay. Yeah, this is not gonna be fun. Let's just make the literal map externally again. I forget what I use this for. Oh. Oh no. Okay, that's great. Okay, we're doing more deduplication in the worst possible way, I guess. So we'll just do it like that. Okay. So we can just call it that. This should definitely take literal map as well. Do I need to give it a ref, maybe? Is that how we want to do it? I forgot about the literal map. That's not gonna be fun to handle. Oh no. I'm really scared of this actually. So what did the constructor for this look like? Okay, it took it by reference. Yes, can we just do that maybe? And then is this, okay, we do just need to pass it like that. Okay. I don't like this. I don't like this one bit. Yeah. Okay. Oh man. I'm really not happy with this at all. This is gonna really suck. Yeah. I think this is probably sufficient for at least like the core lower function. I'm glad that we kept it small this time. This is going to very quickly degrade though, I'm afraid. so let's see. Let's start with a constructor. I think this makes sense. Yeah, so we can do that. We need to give it private fields. Literal map should be LM. It should also be LM. That might be too far. Funds looks wrong to me, so this should be fine. Okay, so we can do that, and then literal map ref LM, like that, I guess. Right? Or yeah, we can do that. Maybe we could give it a pointer instead. I guess this should be a ref technically. Why is symbol table a putter again? Why did I make it a putter? Why is this a pointer? We don't do anything with it. We should just... Oh man. Yeah, why is there discrepancy here? Yeah. So like we don't need a unique pointer for this, right? Or I guess that's supposed to like cut down on space. I think there's a reason for it. I'm fairly sure there is a reason. I think, let's see. Let's ask Claude. Should I use a unique pointer in a struct, or just use the object in the struct? So he'll... Yeah, okay. So I really don't need it here. I don't know why I did it like this. So we can just do that. Everything else can take a... This can take a ref even. Right? And then I guess we don't need to care about the getter too much, right? Okay, yeah. So we should we just have to return a ref, I guess, which is fine. Yeah, sure. Okay, so then we can make this symbol table. Oh, we need to update the constructor. Right? Is that how we did it? And then... Oh, man. See, this is another reason why we're doing this rewrite. To, like, standardize these, like, little things. Because I'm bad at doing this, obviously. Okay, so this does not need to be a ref. Should not be a ref, actually. So we can do that. Okay, this should be a ref again. That's fine. Oh man, we also forgot to rename some stuff here, huh? Okay, nice. Let's see. Do I need to ref that then? Or wait, what? Oh. Duh. We need to update these. Yeah, this is evidently gone poorly. Two-string takes a ref, yeah. So we were like already doing this. We just made it more complicated somewhere down the line. I don't know why or when that happened, but it just did. Maybe doing on paint.net. I was explaining safety versus expressiveness. Or at least like mentioning that that existed, which was interesting. Okay. Let's see, what else do we need to fix here? Oh. That's fine. Okay. So that should all be fine now, I hope. I think the visitor needed to be a putter for some reason. I don't remember why. There was a reason for it. Okay. Oh, we need to update the parser as well, because we do a stupid thing. Ah, god damn it. God damn it, okay. Yeah, I think we have a default constructor for it, right? So this is fine. Yeah, okay. So we can do that. And we can do that maybe, I think. Is that what we need to do? We might need to do that for all of these, right? I guess we don't... Why did we need to specify these again? Oh yeah, there is a reason. Yeah, so we need to do that to initialize them, methinks. Okay, so now we need to fix the rest of this as well. Maybe we should rename this one as well, huh? Now that I think about it. Yeah, so we can do that. That fixes that. Aye, aye. what the hell am I doing? Okay. had to figure that out for a second. We don't need to... do we need to initialize this? I think we do. Does that get default initialized? Okay, so they are. Right? Ah. What's up, Vansu? I am struggling to understand default initialization. Okay. So surely this, I guess we should probably do this anyway, just if we were to like do multiple parses for like correctness. Yeah, I don't like the usage of globals there, but it's fine. Surely it's fine. Okay. Nice. Okay. So now we can go back to looking at this chud file. This should be a ref. Yeah, so we can do that. Right, and then we need to change this putter to a ref. Okay, that fixes everything. That's nice. Okay, alright, okay. So that's one thing done. Get result should be pretty easy. We can just move. We need an internal function buffer. Or we need to make a function buffer of some sort. So we want middle and, or we just want that type actually. So this will just be faster. Or what did we standardize this as like any sort of name in any of our visitors, our like result? I guess we call it res. To MR visitor. That's what we missed. Right? Oh, whoops. Okay. Oh man, this really sucks. This sucks. Okay. I don't want to implement this right now, actually. So we're just gonna do... We're gonna leave these here as to-dos. We'll just paste those. Really consistent. I try to be. There's some days that I skip just because like I'm tired or like school exists. But it happens. It happens on occasion. Generally, I like to think I'm pretty consistent though. Is it possible to make compilers and kernels and to build entirely on Rust? Yes, 100%. Like the fact that like we like the Linux kernel is like gotten some like Rust modules already, and like there are like compilers that are written entirely in Rust. It shows that it's at least feasible. It's just the reason that like it doesn't exist right now is because, well, Linus Torvalds isn't gonna learn Rust and rewrite the entire damn kernel. It's such a large project. So like if some new young talented programmer decides I'm gonna write a kernel in Rust and it's gonna be great, and then they do it, it is very likely that like it would actually be like pretty good. Yeah, again, the big barrier is just that like there isn't someone that like wants to do it, right? So it could be you. You could be the person that starts a Rust kernel. But yeah, I think compilers, I think it's definitely possible. Yeah, it's just like the large projects already largely use C and C++. So a lot of the maintenance work is just keeping that alive rather than doing large, broad swatch rewrites, I guess. Yeah, and like the work for one of my classes is gonna be like testing Rust in the kernel, so yeah. Well, I'll get back to you on that. But in the meantime, if you wanted to write a kernel completely in Rust, be my guest. I'd be very happy to see that. Okay, we'll resolve formatting in a second. Like that. There we go. Okay. What concepts should I be familiar with for low-level programming? You definitely want some like systems knowledge. You probably want some sort of architecture knowledge. Specifically like x86 if that's like the big thing you care about, or ARM if that's what you care about. But yeah, again, just like assembly knowledge, general systems knowledge. So like that falls into assembly, but also like how stuff is encoded, floating point, just like any semblance of an intro to systems class. Bomb Lab is a fun exercise. Some like security fundamentals, just like, I keep saying like the systems pile, but I think that's probably like very encapsulating. You could probably look up like a systems textbook and that should be sufficient. Aside from that, I think you should be comfortable with like OS fundamentals. So like go through an OS textbook and also like do the labs. You should also do the labs for the systems textbook. It's really hard to like learn a lot of this stuff without like getting your hands wet. So you kind of just gotta like, gotta actually do the handwriting code. So yeah, systems, OS, architecture. I think that's probably like the baseline to be comfortable. It would probably be helpful to have some understanding of like networking, maybe some compilers knowledge, but I'm biased in that regard. Yeah, I think if you get through OS and some basic architecture stuff, you should largely be able to figure out what's going on for low-level stuff. There's also a lot of like embedded protocols that are interesting, so I think that might be like helpful. It all depends on like what specifically you want to do with low-level though. Systems intro is definitely like the bare minimum requirement though. Okay, let's continue this. Let's continue this mess. Okay, so we want. Oh no. Okay, so we want this type thing. Yeah, of course. Let me know if you have any questions at any point. What the fuck? Std remove reference. What are we doing? Did you teach all of these? Yes. This is all stuff that like you'll learn throughout college if you take the right classes. there's probably some sort of like systems class in an intro sequence. I'm assuming you're going to school. So like there's usually like an intro to systems course. There's probably some sort of computer architecture course. Usually it's like bundled in with systems, or at least like the basic assembly understanding. But you might find more of that in like computer engineering. Yeah, so that's like, that will probably be covered just through the intro sequence. And then like operating systems is usually like an elective, but you probably should take it regardless of whether it's required or not. It's just so important. But yeah, if you're not like going into school, then there are also textbooks that cover this. So I think that will also largely have you covered. Man, I should make a textbook recommendation list for system stuff. Let me make a note of that real quick so I can do this after stream. Okay. Okay. So, anyways, let's go back to hell here. So we're looking at prototype. So we have a type. We can kind of just like yoink most of this for now, and then we can figure out what to do with this. Let's see. Okay, we have this like unscoped unscoped identifier thing. Currently 14. Oh yeah, you got forever then. If you don't have programming experience, you should definitely start there. I think it will be hard to go through a systems class if you haven't like written code before. So I think learning to program is a good start. Probably getting comfortable with C and then C++ in some combination. In some order, it's up to you. And then like some data structures knowledge is probably good. Your intro sequence should like cover that anyway, but I think it's very largely helpful to get an early head start on it. Like I personally didn't really pay attention during my intro sequence anyway, just because it was like really bland. But the reason I was able to get away with it is specifically because this stuff is like very self-studyable. So I would suggest doing that if you have the capacity to. Okay, this is stupid. We don't need this anymore. We do need to track function. We need to track a lot of stuff again, so we can. Oh man, this private fields list is going to grow. What the hell is internal counts? We'll figure out why we need that at some point. Oh man. Okay, we definitely need those, I think. Vector of unordered set of string. What was I doing? Did it take too much time to learn and feel comfortable with Vim? No, this is a very reasonable question. It took me a month to be able to like do basic work with Vim as opposed to using like VS Code. And it took me about 6 months to get like truly comfortable. And by the 1 year point, I was pretty much as fast as I am now. I don't know what I used internal counts for. I'm sure there was something important, but I do not remember it. Doing backend in TypeScript and OOP and PHP. Okay, yeah, then you should be fine then. I think the next step is probably to like get comfortable with C and C++ then. Because as much as we all love Rust here, unfortunately a lot of the existing both code bases and projects are they're all very C and C++ heavy. So you'll definitely need to be comfortable in that to like, I guess, get through textbook content and also just like work on most meaningful code. It also helps motivate a lot of Rust design choices as well. Like the ownership system didn't really make sense until I had like worked with like pointers directly in C, and then like I was like, okay, this sucks. Unique pointer exists in C++. I'm gonna start using that. And then when I looked at ownership in Rust again, I was like, oh yeah, it's just like unique pointers. So I think that's probably like one example of how like Rust is easier to learn once you have an understanding of C++, and you could make the same argument for C++ going from C. So yeah. I've been using Vesper too much time. I don't know if it's worth the change. Honestly, if from like a strict worth it or not worth it, I don't think it's really worth it. You can definitely be just as fast with just like any semblance of like editor comfortability. But if you think it's fun, or like if you think it's cool, then like by all means go for it, I think. I wouldn't say that like I am like quote unquote much faster, but like I definitely feel fast at least. And also you get to see I use Vim, by the way, which I mean, can't really complain about that ever. Yeah, of course. I still don't know what I use this for. What's up, Panda? Good to see you. Oh boy, this is going to suck. This is gonna suck a lot. I think you should learn C and then, or do some projects with like C, because I think that's very foundational. And then I think getting comfortable with C++ is probably good. Yeah, like most of the big systems textbook labs are in like C. So you'll be really hard pressed to not use it. And then C++ also makes more sense if you're comfortable with C, in my opinion. And then by all means go for Rust, but yeah. Okay, what do I want to do with this mess here? I feel like I should just make macros for this, to be honest. Oh no. Oh no. I'm at the moment where I can't go back to VS Code. Damn. I mean, that is very rough. But like, I don't know. I think if you're in that like weird in-between zone, let me reset my camera. If you're in that like sort of in-between line, I don't think it's that bad to like just make the leap to Vim anyway. So it's up to you on that. Okay, we need to change a lot of this stuff. Okay, let's just yoink all of this real quick. This is also prototype. We'll just yoink all of this. We can do it like that. So we can do F get type, or let's keep this as it was before. So this, what the okay. So this is the slot pile. That's why I woke up in 5 out of 5. Holy hell. Yeah. You seem very dedicated. Yeah, don't forget to get your sleep. Like the reason I canceled a couple streams before is just because I haven't been sleeping properly. So, yeah, sleep really is a cheat code, and it will only get harder to maintain a steady sleep schedule, both due to like doing homework and also like once you go to college, like it turns out everyone kind of becomes a night owl. So there will be like a lot of pressure to generally push your sleep time back. So it would be very helpful to at least build good sleep habits early on. I imagine if you're able to comfortably get up at 5, then like you've already done that, but just like that is something to like stay mindful of as time goes on. Okay. So we want the type, so we can just F get type, then we can just do mir, I think. We can just do that. I'm an incoming math major Should I start learning C++ over the summer? I think C++ is probably the most widely used for quant. Python is used a lot for like glue or like various different scripting needs. You'll probably see some C# here and there, but C++ and Python are largely the big two. If you haven't learned Python, I think that's probably a good start. Like it's just like pretty fun to pick up anyway. You'll probably use it for like coding interviews. So I don't think there's a world where someone shouldn't learn Python. And it's definitely very flexible if you want to go into anything else. Okay, what the hell am I doing here? This is... Okay, what do we need to make the... what do you need to... What do we need to make the thing? We need to yank this. We definitely need this. Spell that. Okay, so we need... Oh no. This is not fun. So we need a type, we need a name, and we need params for the declaration? Wait. Yes, because this is a declaration, because that's what prototype turns into. And we need params. There are many reasons to hate Python, to be honest. The type system I don't really like, or how it like tries to use them and then like doesn't really exist. I don't really like. I don't like the indent based formatting. I don't like that it doesn't use semicolons. There's like more like other fundamental things, but those are just like the initial things that come to mind for me. Why did I have type as a different thing? Okay, well we can type. We can do that at least. Okay, so we need name. What is name? Oh, we need to two-string this. Let's see. I think we can just get the string, right? We can just get name. That's an identifier, and then we want to two-string with st. Yeah, that seems simple enough. Okay, and then the parameters we need to make unscoped as well. But we need to be careful with it. Go is fine. I've heard people just find it really awkward to write, which is also like reasonable enough. Let's start with just like this basic thing here. We definitely need like this line. We can do something with that. Yeah, so we can do that. We want to make a parameter list. That goes up here actually. Okay, so that is like, this is like the very bare minimum we need, at least to make a prototype. Which is like a function declaration, but not quite. I guess it's like a function header, more concretely. Yeah. Let's see. Yeah, this is rough. Oh, wait, I remember why we needed the thing now. There was a thing here. Scope mapping. Or is it this? Wait. Yeah, this is what we needed it for. Oh man. This is so stupid. We should just do a map from I don't even know how we want to map this. We definitely need to track her scope again. I think we also need last expert for the visitor. Yeah, so we're gonna need like these. Oh man. The expert stuff I think we can largely keep the same. We just gotta like change the way we generate code out of it. But that's gonna be a mess. String interpolation, I see. That makes sense. I can see why that's annoying. Okay. So we can do that, and then we also want like this to keep track of the scope. So we're like going up levels as we go here, I think. Or at least that's how I'm organizing it. Okay. So you can do... Man, okay. This is getting difficult. Yeah, so we need a new like numbering system for variables, I guess. Oh wait, no, this makes a mess. Oh, so we should do like, we need to make stack variables. Oh man, okay. We don't need to for this, luckily. I think. I guess let's see. What do we do here? Yeah, so we have this add parameter thing. So we should make a function for that, I think. Maybe we should do like add parameters. Yeah. We should make a helper function for that because we are going to reuse that. So we want like void resolve, or I guess we want to add parameters, and then we want, or this should return a thing. What does this return? Should return a std vector of std unique putter of middle and mir value, and then we want it to take what does this take again? What type is this? Std vector parameter. ST parameter? Yeah. That's stupid. Okay, that's fine. I swear there's a different type for this though that we've used. Right? I feel like there was. I guess not. Okay, that's fine. Okay. Yeah, this is where the function bloat really starts showing up. Yeah. Let's just namespace middle end mir equals mir. We need to do it the other way around, right? Like that. There we go. Okay, what's wrong with this? Okay, too many errors. That's fine. Okay. Yeah, so we can do that instead. Can I actually just... Is it safe to put this inside of here? Wow, okay. Okay, so I can't actually do that. Or I shouldn't do that, rather. So I guess this will be ugly, but that's fine. Okay, so... Oh yeah, now we're getting into like duplicative stuff. Okay. Okay, that's a good start for cleaning this up a little bit. Oh man. I'm starting to regret my choices mildly. I'm clicking the wrong things. Okay. Okay, let's make this add parameters function. Yeah, we'll just to do that again. Actually, we could just put this up here. This we can pass by ref even. Okay, so we can do that. We could do that even. But that overwrites. That's fine. It'll shadow it. Okay. What do we want to do in here? We'll figure that out in a second. So I guess we want to make variable map variable type, maybe. Then add variable to res. What do you think of windsurf? I haven't looked at windsurf, to be honest. I don't know. They both seem, or Copilot seems alright, so I imagine windsurf is probably alright. What's up, Julia? How far along are you with your compiler? Oh boy, I've got a ways to go. I technically have a state of it that compiles a narrow subset of C down to x86-64. Right now, there's like a whole there's a whole stack of things that I'm working on, and there's a big rewrite to like restructure some stuff, clean up some code. All of this is so I can get the deref operator working. All of this is so I can get pointers working, so I can implement arrays. But yeah, in terms of like the actual current state of it, oh, that's not where I wanted to go. Let's not switch tab. Yeah, this is like the subset that I support for now. It's pretty narrow, but there is like some semblance of interesting code you can write with it. Yeah. This is outdated, but I'll fix it eventually. Really want to play around with generative AI tools and make funk edits? I guess that's like, I mean, if that's your idea of fun, then like by all means go for it. I'm like, free will is the thing. Okay, this we can do get, or what do we call this? We'll call it that instead. Yeah, we can do that. Is Arch? Hell yeah. My laptop runs Arch. But yeah, obviously I'm not going to stream off my laptop. I used to actually. If you look at like my very early streams, those were back when I was at home and I didn't have my PC to stream on, so I just streamed off my laptop. And it was like fine, but it was not very fun. Does this work? Oh, neat. Wait, that's actually kind of all we need here, I think. So this should be res equals that. Okay. So I think that's technically like all we necessarily need here. And then from here, the question is like, what goes in the other thing? Yeah, we'll figure that out at some other point though. And then we want like lowered, I guess, function type mappings at name, I think, equals, we can do like type. I forget what I was doing this specifically for, but map function type. Yeah, we'll figure that out once we do that. Do you make yourself a UI? Yeah. My dot files are all in my they're all on my GitHub. They should be starred. But if you look at my earlier streams, it hasn't really changed much from what that was. Okay, we can get rid of that. We might want to deal with scope with that. I'm gonna maybe map the type. I think if you wanted to just like pick some semblance of, if you just wanted to pick a distro to try out, I would either pick like Mint if you have if you're not comfortable with working with Unix, or I'd pick Fedora if you are comfortable and don't want to like build your Lego set from molten plastic. Why don't you make your background transparent? Because there's other stuff behind it, because this isn't a tiling windows manager. Tiling window manager. So yeah, unfortunately, I need to deal with the consequences of that. What's a compiler? It's a program that translates a programming language to another language. So I'm writing a compiler from the C programming language to x86 64 assembly. What motivates you to keep learning and doing stuff? I feel like a chud if I don't. So I kind of gotta keep doing it, unfortunately. Okay. This is kind of just like a one-to-one mapping, I feel like. We need to figure out what other stuff happens in like our add parameter. Oh, that's what happens here. Oh man. So we want allocate store. Yeah, we want that. Okay. Okay. Make allocate plus store. Oh no. What am I doing here? I swear there's a reason for half of this. Okay, I think this is pretty straightforward. So that descopes it. So what am I doing here with value mappings and type mappings again? Oh, I remember now. Okay. Oh man, okay. Map to param. Param name. Yeah, so we need to do that. That also, I don't know if that fits in here. And then we need to do that. Yeah, we'll just do that. Oh, nah. We'll do that. My compiler's in a similar state? I see, yeah. Cogen is like really hard. It quite sucks. I spent like 50 or 60 days on it, so that's kind of how it goes. Doesn't Java do that? Java sort of does it. Dave kind of explained it, but instead of going completely to assembly, it has its own like quote-unquote assembly format. And then when you like run a Java program, it does the rest of the conversion at that time pretty much. There's a little bit more that happens, but that's kind of like the high level idea of how it works. So you can kind of think of it as like a platform independent or like a generic assembly almost. Wait, it's crazy to cancel pizza night for this, yeah. I would not suggest doing that. Pizza night sounds way more enjoyable than watching this. I also might call stream sometime soon. It's been 2 hours. So I need to like get food and also like be a human being at some point. Do you have to take into account the operating system? Not necessarily. The OS operates at like kind of a different level. Let's do a little bit scribbling. So like, you can think of like a computer as like a bunch of different layers stacked on top of each other. So there's like the literal like hardware and like the literal like CPU, like memory, storage sense. On top of this, there is like I guess like assembly language, or you'll hear it referred to as like ISA, which is like instruction set architecture, I think. You'll also hear the term like architecture. You'll hear architecture bundled like somewhere in here. And then the layer on top of the assembly is like the operating system. And then your programs run on the operating system. So, in terms of the compiler, we mostly care about like this assembly because it is like pretty, even though like there is this OS layer, it mostly does redirection rather than like making a completely different language. So we're still like writing quote unquote assembly as the output of the compiler. But that's kind of, and it runs through the OS, but we don't really need to worry about the OS, if that makes sense. That's probably a really poor explanation, so let me know if you want me to try to explain it in a different way. Any advice for studying for long periods and getting things done? Pomodoro helped me for a little bit. But I don't really do it anymore. I think just like blocking out time intentionally is the biggest thing that has worked well for me. But I'm like in this little phase of my schooling where I don't have like too much explicit like classwork, or like my schedule is like more free time than it is busy time. So I probably wouldn't take too much serious advice from myself. I see. Yeah, it's like it is all just like one giant layer cake, and the internals of the cake are always really ugly, I guess. But there is like, you eventually like find beauty in the ugliness somehow, I guess. Okay. Let's see, what else do I need to do here? This is probably fine. We make a name here really late for some reason. I don't know why. And then we actually make the function, okay. So then, okay, we also need to map the function name, I believe. Yeah, okay. In preparation for what was the function? Resolve functions, I believe, yeah. Okay, so I think this is kind of all we need for this little snippet for now. And the nice thing is we can kind of just copy this over to definition for the most part. Yeah, so the only difference here is we need to visit the body somehow. So we want to, how do I handle this? Actually, how do I go about handling this? This is the problem with like doing one big visitor. This is very short-sighted of me. But I'm sure like having all this state in one place is helpful, but like this will make a mess necessarily. So, oh man. Let's see. So we just want to visit f get body, I think. And then, what the hell do we do with this? This is not fun. We want to call resolve bb edges. We want to do that here. And then, oh man, this is terrible. This is really terrible. So that'll link our basic blocks. And then we can make function definition. Okay, what does that take? Oh man. Oh, this is gonna suck. Okay. Okay, so we have function. Yeah, we just do this thing. There's so many steps we need to take. We need to like relinearize as well. Okay, and then we can connect it. I guess create entry block also makes sense. We should probably make that a thing. What do we do in that anyways? Okay, so then this takes all that and then entry. Okay, yeah. So we do need that. So we have type, name, params, and then we want stood, move, basic, blocks. Or actually we could, yeah, we do need that. We also need to add more stuff to the header again. Oh man. There's so much state to be stored here. What can we steal from here to help with this? I guess we just have to do it like this. This is fine. Okay, so we can go up like that maybe. Or we should put all the, like the state stuff in one place. So this is the output. There's those things that we pass in. This is like state. So we should order it like that maybe. This is like inputs. I don't know. It's all convoluted. It's gonna make a mess. I don't care anymore. Yeah, so we can do that, and then we want entry. And then we also want to make a create entry block. Yeah, so we want basic block, create entry block. Oh man. This is getting very convoluted. Do we do this before or after? I guess we do it after. Oh yeah. Yeah, so we should, this order makes sense then. We should do it like that. So we're gonna do that. Oh wait, that's a pointer, yeah, because we just insert it directly in the thing. So we want that to be a footer. This is my final year and my grades determine which college I can attend. Yeah, I mean, that's kind of how the final year always turns out. Yeah, you will get through it, and it will pass. Time will pass. You will pass. Like you will get through it. Okay, we will also, to do that, we'll leave that for a later time. Okay, this all looks good at a glance. Okay, and then we get the name really late for some reason. So, okay. This is all fine then. I think we should move that up like this. Okay. Oh man, there's so much to do. I'm simultaneously really excited and really scared about this. This is also kind of why I've just been like really flaky about streaming as of recent. So hopefully this means good things are coming. Okay, let's make a quick macro here. Or let's make a macro here to finish it all off. So here we want to mir visitor visit, and then we can braces, new line, 0. So we can select all of this and quick find and replace. Okay. So that will all get to dude as well. That will all get to dude. But yeah, let's commit some stuff and call it a day. Yeah. Okay. I think that's what I'm gonna call the stream. I need to eat dinner. I need to make dinner. I need to figure out dinner. So I'm gonna do that now. Thank you all so much for showing up. Like the stream and sub if you haven't. Also join the Discord. It's linked in the description. I think this is also a thing. So we'll see. We'll see if that works. Yeah. Yeah, okay, that works. Perfect. So yeah, join the Discord. Also in the description is my GitHub and my LinkedIn and my GitHub sponsors. So yeah. Take care, y'all. Take it easy. And I will see you all tomorrow, hopefully.